Over the last couple of weeks, something strange has been happening across the AI industry. Within days of each other, OpenAI, Anthropic, Meta, and even China's Moonshot AI all reported AI models behaving in ways they weren't supposed to during cybersecurity testing. Some found and exploited vulnerabilities they weren't expected to. One reportedly even escaped its testing environment. And right on cue, OpenAI announced an entire suite of AI-powered cybersecurity products. Coincidence? Maybe, but I don't think that's the real story. Why is every major AI lab suddenly talking about cybersecurity? Why are they suddenly publishing detailed safety reports, cyber evaluations, and incident disclosures? Did AI suddenly become more dangerous overnight, or did something else change? Now, before we jump to conclusions, let's get one thing out of the way. If you've only read the headlines, it's easy to imagine these AI models somehow escaping into the internet and going rogue. Well, that's not what happened. Most of these incidents happened inside controlled environments that the companies themselves had built for testing. In fact, the more I dug into these stories, the more I realized that AI escaping is just one part of the story. It's more to do with what these companies were actually trying to test in the first place. Because if every major AI lab is suddenly testing the exact same capability, maybe that's where our attention should be. Okay, so to understand why these stories matter, we first need to understand something called a cybersecurity evaluation. Every frontier AI company now puts its most capable models through a series of specialized tests before releasing them. Some of these tests measure whether a model can help develop biological weapons. Others measure persuasion. But one category has suddenly become incredibly important: cybersecurity. So here's how these evaluations work. Researchers create a controlled environment that behaves like a real computer system. The AI might get access to source code, technical documentation, software tools, a command line, or even a browser. Then it is given an objective: find a vulnerability, figure out if it can be exploited, investigate why a system failed, or patch the problem and verify that the fix actually works. The AI is no longer being evaluated on what it knows. It's being evaluated on what it can do. And that's where the word agent becomes important. A chatbot waits for your next prompt. An AI agent doesn't. It can observe what's happening, decide on the next action, use software tools, gather more information, change its strategy if something doesn't work, and keep going until it either succeeds or runs out of options. So instead of answering one question, it's solving an entire problem. Cybersecurity happens to be the perfect environment to measure this kind of behavior because the outcome is objective. Either the AI found the vulnerability or it did. Either the exploit worked or it failed. Either the patch fixed the issue or it didn't. There isn't much room for interpretation. And that's exactly why so many AI labs are focused on it. If an AI agent becomes genuinely good at cybersecurity, the implications are enormous. A security engineer who normally spends an entire day investigating a complex vulnerability could potentially hand that work to an AI agent. Instead of checking one software repository, the agent could analyze hundreds. Instead of testing a handful of patches, it could generate and validate dozens before a human even starts reviewing the results. But here's the catch. The exact same capability that makes AI incredibly useful for defenders also makes it incredibly useful for attackers. If an AI can autonomously discover vulnerabilities before your security team does, it could also help someone exploit those very same vulnerabilities faster than ever before. And this is where some of the headlines become misleading. When people generally read that an AI escaped a sandbox, it sounds almost like science fiction. In reality, these incidents are far more technical. In some cases, researchers found that the AI managed to achieve goals outside the intended scope of the evaluation because of weaknesses in the testing environment, unexpected tool access, or infrastructure issues. The important point isn't that the AI became conscious or decided to rebel. The important point is that these models have become capable enough that researchers are now stress testing the environments around them, not just the models themselves. For years, the biggest AI breakthroughs were about language, reasoning, and coding. But now, for the first time, some of the world's most advanced AI systems are being judged by an entirely different question. Can they perform real cybersecurity operations? And honestly, this is where the story becomes much more interesting. A few years ago, almost every major AI launch followed the same script. Companies talked about benchmark scores, reasoning abilities, coding performance, and context windows. The message was pretty simple. Look how much smarter our model has become. Now compare that with what's happening today. OpenAI is talking about what its models can do. It's talking about preparedness levels, cyber evaluations, trusted access, and why certain capabilities are being rolled out carefully. Anthropic is publishing a better model. It's publishing detailed reports explaining what happened during its safety evaluations. Independent organizations like the UK's AI Security Institute are publicly documenting cyber incidents involving frontier models. Companies are spending almost as much time talking about how they tested the model as they're talking about the model itself. So coming back to the obvious question, why has the industry suddenly decided that showing us how it tests AI is almost as important as showing us what the AI can actually do? And you know what? I don't think there's just one answer. In fact, I think there are at least 3 possible explanations. Okay, so the first explanation is the most straightforward one. Maybe these AI models have genuinely crossed an important capability threshold. For years, researchers have warned that one day AI systems would become capable enough to autonomously discover vulnerabilities, chain exploits together, and perform meaningful cybersecurity operations. If these latest evaluations suggest we're finally approaching that point, then everything we've seen over the past few weeks makes perfect sense. You slow down deployment, you run more evaluations, you publish your findings, and you tighten access. In that world, these disclosures aren't marketing. They're simply what responsible AI development is supposed to look like. The second explanation is that the market itself has changed. A couple of years ago, AI companies were launching products for curious consumers. But today, they're selling frontier AI to banks, governments, hospitals, and some of the world's largest enterprises. And obviously, those customers don't just ask how smart is your model. They ask much harder questions, like the obvious ones. How was it tested? What risks did you identify? Who validated those findings? What safeguards exist if something goes wrong? Suddenly, a safety report isn't just a research document sitting on a website. It pretty much becomes evidence. It tells customers that the company has done the work before asking anyone to trust its technology. But I think the third explanation is the most interesting because it's much more subtle. What if safety itself has become part of the product? And no, I'm not saying AI companies are manufacturing fear to sell AI. I don't think the evidence supports that conclusion yet. But look at how frontier AI launches have evolved. Like I said, companies are no longer introducing a model by talking only about its reasoning, coding, or benchmark scores. They now spend a significant amount of time explaining preparedness frameworks, red team exercises, external evaluations, trusted access programs, and responsible deployment. And those aren't technical footnotes anymore. They're part of the launch narrative itself. A few years ago, AI companies competed almost entirely on intelligence. Today, intelligence alone isn't enough. They also have to convince customers, regulators, and governments that they've understood the risks, tested those risks, and built systems to manage them. It's easy to look at OpenAI, Anthropic, or Meta and assume these are distant Silicon Valley problems, except that they aren't. And as India accelerates its own AI ambitions, this conversation hits directly home. Through the India AI mission, India is actively building it. We're backing indigenous foundation models and scaling sovereign compute infrastructure. But as we build frontier models, we inevitably inherit frontier questions. How do we evaluate risks before deploying an AI inside an Indian bank, a hospital, or a government ministry? Fortunately, that safety architecture is already being laid. The newly established India AI Safety Institute and the National AI Governance Guidelines are instituting a risk-based approach to evaluation, recognizing that a customer service bot shouldn't be tested like an autonomous agent handling critical infrastructure. Even more crucial is evaluating AI for local realities. Take Inspect India Eval, a framework built specifically for our ecosystem. Most global benchmarks judge models on Western context and English syntax. Inspect Indian Evals test models across Indian languages, cultural nuances, localized jailbreak resistance, and safety across our digital public infrastructure. The core systems powering everything from UPI payments to Aadhaar services. A model scoring 99% on an American benchmark means nothing if it hallucinates when processing a regional government workflow or handling financial data under Indian conditions. And that brings me to the ultimate takeaway from this entire story. Like you've noticed, the headlines over the past few weeks were about AI getting better at cybersecurity, but also a reality check that building a powerful model is only half the battle. The harder half is building the systems to audit it, evaluate it, and prove it's safe for the real world. For the past few years, the global AI race was defined by one question: who can build the smartest model? Now, the next phase has already begun, and the question has fundamentally changed: who can prove their model is ready to be trusted? As India steps onto the frontier of AI development, that is no longer just Silicon Valley's challenge to solve, it's ours. If you found this episode insightful and want to hear more such stories, don't forget to subscribe to Tech Brew with Vandana Nair. And I'll see you in the next one.